Hiroshima and Nagasaki,
Yeah.
the uranium
Yeah.
came from the Belgian Congo, which is now the Republic of the
No,
Congo.
I didn't know that. I know there's parts of Africa and parts of Australia that have lots
Yeah.
of uranium.
Middle of Australia
Yeah.
and the Congo and all that area.
These two parts, I think,
Strange,
yeah.
the ones are desert, the ones are jungle.
Yeah, there doesn't seem to be anything in common between the two, does there? I'm not sure exactly what causes the deposits. I know, I know that they're in Australia, and other precious metals too,
Mm.
like lithium, I think, and cobalt, maybe. These are in Australia. But I don't know how they deposit. We all know how oil deposits from
Yeah.
the vegetation and so on, but I'm not sure actually how the radioactive uranium gets in one particular place. Do you know? Did you
Some
read it?
rocks.
Yeah, but how does it get there? Like, what's the process? Yeah, no, I didn't know that. How was your presentation, Harry?
It's good.
What was your topic?
I have the same topic.
Oh, you did it.
Yeah.
Yeah. Good. Okay. And it's just you in one group. You're not with the science students for the presentation. Okay. That makes it less scary, doesn't it? Yeah. Right, so we'll start with a little bit of a tutorial. Were there any problems with the circle questions? Or Gina, you look like there was some problems, was there? No? No? Dorian?
Didn't get to the
Dang.
Sorry.
So no tutorial? Not because there were no problems, but because there was no practice?
No answers.
Did one or two.
Is it because you had the presentation? Or you're just tired or what? You think about the holiday?
No, it's just that we had a thing with the houses and stuff.
Oh, thing, huh? Guys down the back, did you try any of these last night? Harry, you tried some? 5 questions, okay. And how were they? No problems? Are you sure?
Can you actually do the number 2?
Yes, I can do this one, yes. Zach, did you try any?
I didn't get to do it.
Did you try any of them?
Yeah, so for questions I don't get it, still don't get the
Question 2?
Yeah.
Okay, let's do number 2.
But I looked at the answers and it was
Okay.
what?
Okie dokie. Number 2. Can you read it, please? Okay, this will be easier.
And then the equations they used, they are weird.
I'm not sure if you need to use them.
Yeah, well, there's always, there can always be more than one way. Let's have a look. Cantilevers. Conservation of energy. Power and efficiency. Where the heck is it? Collisions. It's after collisions, isn't it? Yeah. Ah, yeah, this number 2 is a little bit tricky. Yeah. A mass of 2.65 is attached to the end of a 1.34 length of string. The string is fully stretched out in a horizontal direction and the mass is released so that it falls in a circular arc. Determine the tension of the string when it's at its lowest point. Here you go. So basically what's happening here is it's just swinging around in a circle like this. Okay? And they want to know when it's in this position, what's the tension. Yeah, now it's actually, I don't think we have to use kinetic energy. It's possible not to. Okay? Or maybe, no, maybe not. Did it say it started, it said it started horizontally actually, so I kind of drew this badly. I should have, this started horizontally. Well, it started like this. So actually I might not even go all the way around. So maybe I'll just delete this part. hope you know what I'm doing. Okay. What did we say the length was? 1.35, was it? 34. Okay. I think you're right, actually, Zach. I think we do need to get
Where can you use maths?
the potential energy here will equal the kinetic energy here. So that means a half mv squared equals mgh. The m's cancel, so I get v is root 2gh, which will be 2.68 times 9.81. What's that, please?
5,130 or 5,127.
Like that? So, guys, when it's down here, it's moving in a circle, isn't it? Yeah? So, that means the force, which equals ma, which equals mv squared over r, which equals 2.65 times 5.127 squared divided by 1.34, that equals 10.14 newtons. Okie dokie. Now let's have a look at this in more detail. How many forces are acting on this?
Tension.
And which is bigger? Right. Correct, it's centripetal force, it's moving in a circle. So it must be that the total force, which equals 10.14 newtons, that must be because of the T minus the mg. This must be bigger than this because you want to picture where there's force to the centre to make it move in a circle, circular motion. So
2.65 times 9.81 is greater than that.
say again?
2.65 times mg
Yeah.
is bigger.
Well, hang on, let's say 10.14 equals T minus, and what's this?
25,99.
Huh? 20, oh yeah, fine. Yeah, 25.99. So that means the T will be 36.13 newtons.
Is that what you got, Gabe?
No, I didn't. I started with
It's a bit tricky.
So the centripetal force is 10.14, but the tension is
It's not this.
because the centripetal would be the resultant.
Correct, it's the resultant, yeah.
This one is quite difficult.
It is a bit tricky, isn't it? You better write it down and we can continue. got that written down? Yeah. Yeah. Okay, let's close this. So you should try some of these when you get a chance, okay? Because you can see that they're a little tricky. You know, they're a little tricky. But we'll go on to the next lesson now.